Now that we have an idea about the effect of round-off error, we can actually compute some estimates. So, for the forward Euler method, the total error is composed of two parts. The part due to the Euler method, the global truncation error, if you remember that term, a constant times the step size, plus the error due to round-off, which seems to be proportional to the number of steps and hence inversely proportional to the step size. Epsilon denotes the relative size of the error. It's something like 10 to the minus 7 or 10 to the minus 16. By which fraction does our number tend to change due to round-off? Again, we should see proportionality here. If we have twice the amount of error in each step, we should be seeing twice the amount of total error, even though, again, the error introduced in the earlier steps is growing over time. And d is some proportionality constant that we don't know yet, and that depends on the problem, as does c. So there's one component to the error that grows from 0 to infinity, in principle, and there's another component to the error that starts at infinity and decays to 0. We have to have a minimum in between. This is what we saw in the experiment. Let's call the step size at that minimum h min. It does not make sense to use more steps, that is, to use a smaller step size, because the error will be growing again, due to round-off. Now here is a quiz. For the two types of floating point numbers that we're typically dealing with, we can specify the value of epsilon. It's about 10 to the minus 7 for single precision. In C and related languages, that's called float. And it's about 10 to the minus 16 for double precision. Python works at double precision, and the arrays of NumPy can be configured as to which precision they should be using. Now here comes a quiz. Say we do an experiment at single precision and find that the value of h min amounts to 10 to the minus 4. If we try to solve the same problem at double precision, what do you expect to be the value of h min? Pick one of these. 3 times 10 to the minus 9, 4 times 10 to the minus 10, 5 times 10 to the minus 11. Here is a hint. At the minimum, it turns out that the contribution of both parts is the same. CH will equal d epsilon over h.